We are passing through problems. We are passing through some transitional periods. Transitional periods in everywhere, every sectors. Similarly, in the field of energy, also, there is a problems of energy. What are the different energy that we are using? That's mainly comes from the fossil fuel energy. So the fossil fuel energy has several problems. Problems like its uh, means scarcity, means how long we can last with the help of these kinds of energy. That has a big question marks, as well as it has a adverse environmental effects. So we must know the importance of the energy. That's a very much important. Everywhere, everywhere you needs energy. Without having energy, you can do anything. The are the basic needs of the human beings. The Anna Vastra Vasastan, that's we know. Apart from that, we need fresh water, we need health security, we need education, proper educations, and also there are other several aspects are there. That's a very important, and we consider that these are as a sustainable goals. So United Nations defined like that way. There is 17 sustainable goals, and energy is one of the key parameters of that goals. And in every goals, if you want to achieve that goal, so everywhere energy is linked with that. Without having energy, you can do anything. You cannot achieve anything. So these are the things that I mentioned. So the problem is energy crisis, but we must have energy security, and the problem of global warming, like due to the climate change, global warming, climate change. But we must have sustainable developments. As we know, we are the third world countries. We are actually developing countries. There are three kinds of countries we can define as developing and the underdeveloped countries. We are Indian as a developing country. So in any kinds of development, so energy is the key parameters. Key parameters means if you consider a developed countries like USA, you will find the per capita energy consumptions is far more than that of India. What is per capita energy consumptions? Per capita energy consumptions means the energy required per head per year. So how much the energy consumed by persons? If we consider USA, so that per capita energy consumptions is more than 7,000 kilowatt hour. So in terms of kilowatt hour, that is the unit of electricity that we know. And in case of China, it is around more than 3,500. And in the world average, you find it is around 2,400, 500, like that. And whereas as we are Indian, per capita energy consumptions for our case is around 1,100 to, I think now it is becoming 1,200 kilowatt hour per head per year. So from these statistics, we can understand the positions of the development positions of ourselves, where we are residing, where we are lying. We are below the world average. So but we have to develop. We have several initiatives, we have several programs taken by the government, and we are doing as well in everywhere. So you have to increase the energy consumptions, but the problem is the energy, where from that energy will come, because we have a limited resource of petroleum, very limited. Natural gas, that's mainly fossil fuels, but we have a quite good amount of coals, but that's will not be sufficient for a far period of times, long periods of time. So we have to find some alternative resource. What are the alternative resource? Alternative resource is nothing but the renewable energy sources. So you see what the energy we are using nowadays, that is the global energy mix scenario by 2015. So what is the positions of it? It is up to 2023, but the trend is given like that way. You are finding these are the coals, natural gas, and petroleums. That's how we are using. But that is the green lines that you can see. The trend is changing. That's green line means the uh, use of renewable energy. So that renewable energy is increasing day by day, and we hope by 2050 the renewable energy sources will replace all the kinds of fossil fuel based energy. And that obviously that will be because there has we have no any other alternatives. And government of India uh, declared we must be a carbon neutral country by zero emission country, a carbon neutral country by 2070. So that's a big target that we'll try to achieve, obviously. So for that, what we have to do, we have to go for renewable based of energy. You can see the present status of the energy used. Actually, energy are different forms. Mostly here, what's the tables is showing here, that's are based on the electricity. As the electricity is the clean sources of energy, so very clean means if you have the electricity, you can go any routes. You can do anything, and also any kinds of energy like thermal, wind, or etc. Whatever mechanical energy that you can convert it to the electricity. Here the table shows the electric part. The installed capacity that's is up to 2023 to 2024. It is showing is around 4041. Nowadays, it finds is around 4000, more than 60. 4060 gigawatt, and out of that you'll find there is a quite good contributions of renewable sources of energy, and here it is showing is around 143 gigawatt, but nowadays you'll find is around 165, more than 165 gigawatt. And out of that, the mostly the solar energy that is around 100 gigawatt, and the wind energy is around 45 gigawatt, and rest are the other sources of renewable energy like biomass, biogas, etc. And also there is a part of hydro energy, and hydro energy potential is also quite good. Hydro energy is 46.45 is around 47 gigawatt, and considering all this we will have more than because hydro is also renewable energy. So considering that, we nowadays we will find the installed capacity of total renewable energy is more than 200 gigawatt. So it is quite good nowadays. But we have to replace all the fossil fuel based energy because thermal energy installed capacity is around nowadays is around 57%. So that needs to be replaced by other renewable energy sources. Then only we can say we are carbon neutral country. So this is the carbon emissions. Already mentions the problem of fossil fuel based energy because fossil fuel based energy are carbon based energy, hydrocarbons. So mostly carbon dioxide, carbon is maximum in case of coals, but hydrogen percentage is increased in oils, and after that in the gas. And we know the hydrogen is a clean fuel, but as the carbon is present there, so it produces the carbon dioxide, and that contributes to the as a greenhouse gas in the environment. And the effects of carbon dioxide. That's a greenhouse gas, main greenhouse gas, and that allows the solar radiation, short-wave solar radiations, but restricts the long-wave radiations that returns from the Earth's surface to the universe, so that it maintains a uniform temperature all over the Earth. But the problem is if the carbon dioxide percentage is more and more means, as we know, the carbon dioxide percentage in the year is very less. It's 0.3%. So 0.3%, but if the concentrations is get changed or increased a little bit, has a huge impact on the environment, because that will trap the energy, and trapping the energy in the Earth atmosphere will increase the average temperature of the Earth, and that causes the problems of melting of glaciers, means the climate change, etc., etc. So uh, that we are observing. So what about the rain yesterday night, the rain fall? So it's a cloud burst rain, and that is happening repeatedly. So these are the effects we can observe of the climate change, and that is due to the emissions of carbon dioxide, and that mostly that carbon dioxide comes from the energy sectors. And these are the this slide shows the what are the different sources are there and where the most of the carbon dioxide gets emitted. So we have to restrict the emissions. Some of the cases that we can't do anything, but we can restrict the energy sector, agriculture sector, etc. So, but we have to understand the concept of carbon footprint. What is the carbon footprint? Carbon footprint is the amount of carbon dioxide emission per generations of unit quantity of energy. Unit amount of energy. Unit amount of energy means the it may in terms of kilojoule, megajoule, or it may in terms of kilowatt hour. You see the last column. This is the different resource. If the energy produces from the coals, then the carbon dioxide emissions is around 1000 to 1200 gram. Means 1 unit of electricity means 1 kg of carbon dioxide emissions to the atmosphere. And if it is comes from the oils, is around 700 to 800 uh, gram. Whereas in case of nuclear, so it's quite low, but it should not be. But it is showing some values because of that. It is inbuilt carbon dioxide. We know the nuclear power plants have no emissions because there is a nuclear fission reactions that takes place in the reactor, and that fission reactions will not have any carbon dioxide emissions. But the processings of the fuels, what the fuels used in the power plants, that are not available, readily available. So the fuel is taken from the earth, from different minerals, and that needs to be that needs to be refined, and needs to be purified, and during that process, and that needs to be enriched. So term is enriched fuel. During that enriched means of that fuels, used energy is needed, and most of the cases that energy comes from fossil fuel based of energy, and that's why it's showing the carbon dioxide emissions. Similarly, in the hydroelectricity, we know there is no carbon dioxide emissions, but it is the inbuilt carbon dioxide emissions is very less. Whereas in case of photovoltaic systems, means solar system, solar cells, by producing solar cells, extractions of most of the solar cells that are made by the silicon material, and the extractions of the silicons from silica, silicon dioxide, that's are nothing but the sand, is huge energy intensive process, and for that there is a inbuilt carbon dioxide for that purpose also. Similarly, in wind energy, wind electricity, there is also inbuilt carbon dioxide is around 20 gram per kilowatt hour of electricity generation. So already I mentioned the problems of climate change, problem of global warming, problem of energy scarcity. So what's the options? What we can do? Obviously, we have some alternatives. So that's are termed as energy management options. So how you can manage your energy use, energy storage, and energy transportations, energy conversions, etc. Firstly, we have to go for the renewable waste of energy based on the location available, whatever the resource are there. Based on that, you have to choose your conversion systems for using more and more amounts of renewable energy systems. But you know the renewable energy systems has a problems of intermittency, means sometimes it is available, sometimes it is not available. So that is the main problems of the renewable based of energy. But you have to use there are various various source means, so it may solars, it may winds, it may biomass, it may hydro, it may uh, geothermal, it may ocean energy. etc. So based on the resource available, you have to use that resource in judicious manner. So that is the options. Now coming to another options, that is energy conversion. Energy conservation. Energy conversion means one form of energy you can convert to another form of energy, but the term is energy conservation. That is the main things of energy management. Means whatever the energy we are using nowadays, and that's mainly comes from the fossil fuel based energy, and that needs to be conserved. That does not mean that without with just you, I am telling you to sacrifice your livelihood, sacrifice your status. What you can do, you just don't misuse that kind of energy. Whatever is required, is how much is required, you just use that amount. You don't go far beyond that. So you have to use that energy in judicious manners. That means that is the savings of the energy. You know, while telling about the savings of the energy, you know, the energy that's come from the fossil fuel based of energy, and if it is a coal based thermal power stations, and the coal based thermal power stations have a very low efficiency, means the efficiency, overall efficiency of the coal based thermal power plant is 30%. Okay, then that means whenever that energy produces in the power stations, that then through the transformer substation then feeds to the grids. If power is transferred from grids, means the sending stations, means sending substations to receiving substations, then further step down transformer, then we use it in our house or households. Then there are some appliances, means it may bulb, it may fans, it may other motors, it may other appliances, etc. And everywhere there is some losses. Means whatever the energy is produced in the power stations, after that, if you consider all the losses, you will find you can use only 20% of that energy. Means you are producing 20% of the energy, you are supplying the energy at the power stations is 100% in terms of coal, but using is 20%. That means 1/5 of the energy you can utilize. That means you can think in the reverse way, you can save 1 unit of electricity in your households. That means you are saving 5 units of energy in terms of coal in the power station. So that is the beauty of energy conservation. So an equivalent amount of carbon dioxide you can emissions you can reduce. So there is another option is the energy efficient technologies and the process. And the energy efficient technologies means the whatever the appliances or systems will use, that should be in energy efficient systems. Energy efficient systems will have more efficiency. It will consume less amounts of energy with having same amount of output. So then only you can save the energy. And you know, nowadays we are using different appliances with different star rating, 5 star, 4 star, 3 star. Especially in case of home appliances like refrigerator, air conditioning systems, or microwave, oven, induction cooker, etc. So there everywhere there is a star rating, and that star rating is provided by Bureau of Energy Efficiency. This is a part of the Ministry of New and Renewable Energy, Government of India. They provide that certifications, means more star means more energy savings, more efficiency. So we have to concern about that process also, and we have to use that kinds of system to reduce the our energy consumption, subsequently to reduce the carbon dioxide emissions. And proper energy planning should be there. They are based on the energy available. We have to plan accordingly. Education, awareness, and capacity building and training is very much essential everywhere. We need to have some training programs. We have to local awareness programs in university level, college levels. We do. We are working. We are attending conference seminars, and we are arranging some programs also. But for the local peoples and the means para in para level. if we can build some awareness programs, then it will be helpful totally for our country and for our future also. So there is a concept of energy efficiency that I am not going for details of that. So increase energy efficiency, there are different processes are there. Good housekeeping, regulation standard, industrial cogenerations, waste heat recovery, fuel switching, fiscal policies like tax, rebate, subsidies, benchmarking, energy audit, and research and developments. And rebate means that will provided by the government. That government should take initiative so that more and more people will get interested on the energy efficient systems as well as renewable energy based systems. This is the different renewable energy conversions. If we categorize, so these are the different routes of the renewable energy. Means the energy from sun, whatever the energy that directly coming from the sun, and the geothermal energy. Geothermal energy, that is also the energy that from suns at the time of birth of our earth. That energy confined within the earth crust, and sometimes it comes in the forms of hot water, steam, and that steam and hot water, if you can use, so that is a part of geothermal energy, and that is in terms of magma within the earth crust, and when that magma comes near to the earth surface, so then only you can use that. And for that case, it will have the higher temperature gradient. So the temperature gradient should be high for that case for utilization purpose. Otherwise, it will not be economical. And next, the energy from the sun. Energy from suns may be divided in two types: is solar direct and the solar indirect. And in solar direct means means whatever the solar radiation that is coming on the earth surface, that you can use in the forms of solar thermal and in the forms of solar photovoltaic. Solar thermal means everywhere we need some hot water, we need some hot air. So hot air, hot water, so that can be prepared, that can be produced with the help of direct solar radiations with some converting system. So solar dryer is also there, solar steel is also there, that is also solar steels means solar distillation plant, means water can be distilled with the help of solar energy. Solar pond is also there, solar thermal power plant is also there, means by using solar thermal, by using some concentrator, you can produce the steams, and that steams can be used for power generations, and that can be used for other purpose also. And in the households, in case of households, we need some hot water in kitchen, hot water in bathroom. So that can be obtained with simply if you have a solar hot water systems, it is readily available in the market. So that hot water systems will give you the hot water that you can utilize, and that can reduce, if you use that hot water for cooking purpose, that can reduce your LPG gas consumptions is around 60%. Okay. And next, the solar photovoltaic. Solar photovoltaic is the direct conversions of the solar energy into the electricity. Solar energy means the solar radiations. It is nothing but a semiconducting device where solar radiations comes, and while solar radiations falls over that systems, then it converts to the electricity. So that is the solar photovoltaic routes, and that electricity you can use in the forms of DC, you can use in the forms of AC also, if you have using some inverter or some controller. So, and solar indirect systems. Indirect means the solar energy. Without having solar energy, you don't have the wind energy, you don't have the hydro energy, you don't have biomass, biogas, you don't have energy from oceans, because everywhere in the wind energy is nothing but that is due to the differential irradiations at different location causes the change of density, causes density difference of the air, and due to the density difference that hot air goes up and creates some vacuums, and the lighter air from surroundings comes to midst of the vacuum, and that is the wind energy, and that means that it is a indirect solar energy, and that you can use with the help of some converter, that is the wind turbine or the wind mills, etc. Windmills or wind pump is also there. You can get that energy. And hydropower, there is a rain cycle. Without having sun, there will not be rain cycle, there will not be rainfall, not be the flow of water over the surface, flow of water in the rivers, and that's why it is the indirect solar. And biomass and biogas, biomass is a plantations, and that by absorbing the solar radiations in the process of photosynthesis, so it biogas and plants produce the foods, and it survives. Okay, and that the energy confined within the biomass, so that comes from the solar energy. Okay, so that's why it is indirect solar. And energy from sun means the wave, tidal, and ocean thermal energy conversion technology, that is also the indirect solar energy. So this is the renewable energy potential in India. So there are different type of source given here. It is state wise. I think it will not be visible. So anyone interested can get in the website. It is available. It is available in the website. What is the status? What is the how much amount of resources available? Renewable energy resources available in India. You see the last column. India have and the solar energy part. Solar energy part is around 748,990 megawatt, means is around 750 gigawatt of solar energy that can be harnessed available in the India. So we have a big resource of the solar energy we can utilize. Presently we are using is around 450 gigawatt, and the only the solar energy potential is around 750 gigawatts. So compare the figure. So we have enough amounts of solar radiations. So that you can see from these slides how much solar radiation is there. If you go for the solar energy system, so solar energy is the main thing, is the main source of the energy. So you have to understand the solar energy, how much it is available, why it is available, why it is not available. And the solar energy means the India receives on an average 4 to 7 kilowatt hour per meter square per day. 4 to 7 kilowatt hour per meter square per day of solar energy daily. We can average of 250 to 330 days in a year. And obviously Rajasthan, Gujarat receives maximum radiations, and also Kerala. Maximum radiations in the range of 6 to 6.6 kilowatt hour per square meter. And in Kolkata, we have around 5 to 5.5 kilowatt hour of solar radiation. So it is quite enough to build a solar power station. So this is solar photovoltaic principle. It is developed. It is first observed by Alexander Edmund Becquerel in 1839. So it is nothing but a conversion of solar radiations to the electricity with the help of some semiconducting devices. So the solar photovoltaic art of converting solar energy directly to electricity, that's already mentioned. It's a device. A device means it's nothing but a semiconducting diodes. It's a PN junction diodes. Mostly, what about device we are using nowadays is 90% is from silicon based material. So p type material and n type material, there is a junction, and while the solar radiations absorbed by the semiconductor, it creates additional holes and electrons due to excitations by the photon energy from solar radiation. And if you can separate, it is not showing here, uh, that electrons and holes, so you can develop an voltage. So that is a photovoltaic effect. So it is termed as photovoltaic effects. And how the question is how we can separate that electrons and holes. That can be separated with the help of some electric fields, and that electric fields is developed by the help of p-n junctions. You know, if the n-type material, p-type materials, if there is a sandwich forms, if it is then there is exchange of electrons and the holes with, across the junctions, and creates some depletion layers. Okay, and at that time it becomes some polarized. So there is it develops some electric fields, and that electric fields will help to separate the additional holes and the electrons created by the solar radiations in the photovoltaic, in the silicon or in the silicon materials, in the semiconducting materials. So this is the configurations of the solar cells, simple diagram. At the top you'll find some transparent covers, then some anti-reflection coating, then some at the top so cover glass will be there, and there is some front metal grid to collect the electricity or charge from the top. And then there is a n-type semiconductor, and then there is a p-type semiconductor. Then at the bottom you'll find some back contacts specially made by aluminum, and the front contacts are made by silver. If you see the solar cells, you will see some white lines like a threads over the at the top of the cells, and there is nothing but the metal contact of silver material. So this is the different figure of merits of SPP cells. Figure of merits means the performance parameters. So everywhere, if you want to design some things, you have to understand its performance, how well it is working. So it is short circuit current, open circuit voltage, maximum power, current at Pmax, voltage at Pmax, fill factor, shunt resistance, and the series resistance, and the efficiency. Efficiency is the main thing, means how much input is there and what is the output. And input means the solar radiation. So if you want to determine these performance parameters, you have to go for these figures. It's not clear quietly because of using these phones. So these are the cells. There is some load is connected with variable loads with some voltmeter and some ammeter is there. And if you change the load resistance, so it, with having some illuminations means below the sunlight, so you'll find different values of current and voltage respect with depending on the resistance you put in the circuits. Okay, resistance is changed from 0 to infinite. In the 0, that means it is short circuit conditions, and if it is infinite, so it is open circuit conditions. You will get the open circuit voltage, and in between for other values of the resistance, you will get different points. And if you plot that points on the curves like IV characteristics, so you will get the curves like this. So you find some knees. In the VOC conditions, in the open circuit voltage conditions, there is current is 0, so power is 0. And the ISC conditions, mean the short circuit conditions, voltage becomes 0, so power is 0. But we are concerned about the powers. So you have to find the point where the product of V and I is the maximum. So that is the maximum power point condition. So that is the knee points. So it is considered as the maximum power point, and corresponding voltage is called Vmax, and corresponding current is called the I max. And this is the equivalent circuit of the solar cells. If you consider a solar cells is nothing but a current source like light current generated due to the light with having some diode because it is a PN junction diode, and with some series resistance. And series resistance, that's the resistance of the material, means the whatever the charge is generated within the material that needs to be transferred to the metal grids, and for that it faces some resistance by the material itself, as well as there are some contact means contact of semiconductor to the metal, and also some wear is also there, and that is the resistance, that is total resistance. So it is RS, series resistance. And shunt resistance means the resistance between the P and N side of the material. And obviously there should not any current pass through through that junctions, because if the current pass through the junctions, so you will not get the current at the external circuits. Okay, so there will be loss. So that is that this shunt resistance should be as much as possible. In ideal case, it should be infinite, and series resistance should be 0. And you can avoid the diode. Diode is also there, and there will be some diode saturation currents that will flow in the circuits that will remain. So that is a part of the loss. You will not get that one. Okay. So it is the short circuit current. So that can be calculated with the having of these equations. You know, considering these equivalent circuits, if we consider shunt resistance is infinite and series resistance is 0, so you'll get the equations. I means that the current passing through the load will be equal to the IL minus I0 into e to the power QB by KT minus 1. Actually, it is QB by AKT. A for diode ideality constant, and for silicon solar cells it is considered as 1. So that's why it is not given here. So an IL is the current generated due to the light, and I0 is the diode saturation current. Q is the electronic charge, V is the voltage across the load, and K is the Stephen Boltzmann constant, and T is the absolute temperature. So this is the current, and considering ISC conditions means V will be 0, so you'll get the IL will become the ISC. Short circuit current will be equal to the current generated due to the light. Similarly, in case of open circuit voltage, so you'll get the equations like this: VOC equal to KT by Q, LN, IL by I0 plus 1. And that you can achieve if the IL is 0, then I is 0. So I is 0, so you'll get the equations like this. I means load current is 0. So and you see from the equations, VOC will be proportional to the log of IL by I0 plus 1. And you know IL is the light generated current, and I0 is the diode saturation current. As the ratio is quite high compared to 1, so you can neglect the values of 1. And I0 is a constant for a particular type of device, and KTQ is also constant. So VOC is directly proportional to the log of IL, and IL means the light generated current, and that IL is directly proportional to solar radiation. Okay, that is the observations by the Becquerel. IL is the directly proportional to the solar radiations, and that's why VOC is directly proportional to the log of solar radiations, and that is the cause. If you change a solar radiations, there will be very less change of voltage in the solar cells, whereas in case of current, it is directly proportional. It is directly proportional means I means load current is directly proportional to solar radiation. So there is another term is field factor. It is nothing but the property of the material. It is the combined effect of shunt resistance and series resistance. Shunt resistance and series resistance mainly depends on the device and its material. And what is it? You see, fill factor can be given by the maximum power from real cell, means Vm into Im, whereas to the ratio to the maximum power from the ideal cell, that is VOC ISC. Ideal cell means, in the ideal cell, if shunt resistance is infinite and series resistance is 0, so the ideal curve will be that blue one. What was the blue one is there? That will be the ideal curve, just like a rectangle. And in that case, Vm will be equal to the VOC and Im will be equal to the ISC. So that is the ideal cell. So that is the fill factor. So actual cell by the ideal cell. And for silicon material, the values of fill factor is around 0.75. So this is the efficiency. Efficiency is nothing but VMIM by P in. What is P in? P in means the solar energy input on the cell. Solar energy on the cell means if you have to measure the area of the solar cells and whatever the solar radiations that comes on the earth surface in different forms. Okay, we can divide it is terms as a global radiations and the total radiations. That's a two part. One is beam radiations, another one is diffuse radiations. And the beam radiations and diffuse radiations percentage depends on the conditions of the climatic conditions of the sky. Okay, and it is defined by sky clearness index. Okay, and if it is good, then the percentage of beam radiations is around more than 75%, and diffuse radiations will be less than 25%. Okay, but if it is bad, so it's like students' environmental conditions, the clearness index is very less, so beam radiation components will be around less than 25%, and the diffuse radiation, mostly the radiations comes, that is in the forms of diffuse radiation. Clear? And knowing the values of beam radiations and diffuse radiations and how much percentage, means how much amounts of solar radiations coming over the surface of the solar cells normal to the surface. So what in terms of watt per meter square into the area in terms of meters will give you the total solar radiations on that solar cells, and that you can measure directly with the help of some instruments, and that instruments are termed as or named as solar pyranometer. Solar emitter is also there. Solar pyranometer is the basic instruments that will measure the total radiations, and with some special arrangements you can directly measure the beam radiations. You can measure the diffuse radiations, and subtracting that diffuse radiations from the global radiations, you can measure the beam radiations. Okay, so that is the concept, to measure the efficiency of the solar cells. And by using some loads, getting some IV characteristics, you can get the values of VOC, ISC as well as fill factor from the of the cell. We are talking about the solar cells, but you know the solar cells that's made by the silicon, if it is around 100 mm square solar cell, 10 centimeter by 10 centimeter, it will produce the current is around 2 amps and the voltage is 0.5 volt. So voltage is 0.5 volt and 2 amps means from one cell you can produce is around 1 watt of electricity. Okay. And you know, you can if you increase the surface area, you can increase the current, but you can't increase the voltage level, because voltage levels depends on the barrier or the depth of the depression layers. Okay, so and also the uh, it is termed as band gap of the material, optical band gap of the material. Okay, so for the silicon solar cells it is around 0.5 volt, but means 1 watt you are getting 1 watts, but we are thinking about gigawatt, megawatt, kilowatt, megawatt, gigawatt level power plants. And to have the gigawatt level power plants, you have to increase the voltage levels as well as you have to increase the current levels. So how we can increase the voltage levels? If you connect the cells in series, then and if you make some module, so it is starts a solar module. So in the solar module, several numbers of solar cells are connected in series and make a panel, and confined within that panels is start a solar module that will help to increase the current, voltage only, but the current remains same. Uh, Better to say current get decrease because of the series resistance of the series resistance of the materials of the cells connected in the series. And further, if you want to increase the voltage, so you have to connect all the modules in the series. So it is termed as solar array, solar string. Solar string, the solar cell to solar module, then solar string. And further, if you want to increase further current, so if you connect all the strings in parallel, so that will help to increase the current. So you have more voltage and you have more currents, and this configuration is termed as solar array. So whatever the power plants is available, in case of large power stations, there is a large arrays of solar modules are placed in the power stations to have large amount of power. So this is the construction slide, shows the different parts of the solar cells, and from solar cells to modules. So I am not going details of that, already I have described it. So now the from solar cell to module and the solar array. And you know, in the power stations, solar cells is the essential part, obviously, but it's not sufficient. So there are so many others: controller, device, wiring, switching, gears are required. And also, if it is a standalone system, obviously some storage arrangement should be there. And storage means mainly the battery storage. Okay, a battery storage, and nowadays the hydrogen storage is also coming. Means the green hydrogen, we can produce the green hydrogen by using solar energy, and that hydrogen you can store, and whenever is energy required, you can convert that green hydrogen to the electricity with the help of fuel cell. So electrolyzer to produce hydrogen, then fuel cell to produce hydrogen to the electricity. And nowadays in the same electrolyzer and same fuel cell, the same electrolyzer can be used as a fuel cells also. And also there are another form of storage, means the hydropower station, pump storage hydropower plants. The pump storage means pumping what can be done with the help of solar energy, while the solar energy available in the daytime, that can be used for storing purpose, and utilize that energy and convert that energy at the night time while solar energy is not there, and by passing that water from top to bottom through some converter. Converter means the hydro turbines. So these are the concepts. So these are the different systems needs to associated with this to have the reliable operations of the systems. Otherwise, it not be reliable. So these are solar photovoltaic power plants. So type of solar photovoltaic power plants: standalone off-grid power plants, grid connected centralized power plants. Off-grid power plants means the electricity is used in the charge to charge a battery bank. This power is converted to AC for powering loads. And also grid connected centralized systems deliver electricity directly to the grids through inverter during sunshine hours. And the grid connected distributed systems means it may be grid connected systems, it may be central grid connected systems, or it may be standalone distributed systems. It is mainly designed based on the local resource available. There will be some common grids, and there may be a different types of resource. We have different types of converter may connected with that grids, and that grids is locally connected with different loads to provide. And obviously, if it is not centrally grid connected systems, for stability of the system, some battery backup or other storage arrangements is needed, or storage arrangements or may DC sets also may needed to run the systems. Also, the biomass is also another options is there for remote areas. That biomass can be converted to the usable fuels like liquid or the gaseous fuels that can be used in the DC sets to generate electricity, and that electricity can be fed into that local grids also. So this is the concept. And nowadays, and actually we are mostly using the centralized grid power, but the future is the grid connected distributed systems. In future you'll find there will not be any grid connected systems. Central systems will not be there. Obviously there will be grids, but all the distributed energy systems will be connected with that grids, but we have some facilities while it is needed, that may be connected with the grids. If it is not needed, it can get disconnected from the grids easily. So that facility should be there. So there is some smart approach, or the smart grid concepts is coming in future. So off-grid solar applications, so these are the different applications that mobile tower is also there. Solar energy you can use. You can use the clinic, you can use the building mounted photovoltaic systems, rooftop power plants, you can use open canal systems, you can use floating power plant, you can use in the remote areas for drinking water, drinking purpose, you can use to preserve the solar refrigerator, to preserve the medicines and etc. And nowadays you can use in houses also the solar refrigerator, solar air conditioning system is available in the market. Now the grid connected SPV systems, grid connected means you see that systems is directly connected to the grids. So no needs of energy storage. So but the problem is at the night time solar energy you have to take the energy that is from the grids. But there are different options is there that we can use. If you are connected with the grid systems, you can install the power plants at your rooftop. So installing the power plants at the rooftops will give a huge savings in your electricity bills. How it is? You are while radiation is there, you are using you are generating and you are delivering that power to the grids as well as you are using. And while radiation is not, solar radiation is not there, you are taking the power from the grids, but at the end of the month, whatever the plus minus, how much energy you paid to the grids and how much you are taking from the grids, so there will be some calculations, and based on that you have to pay the bills. But the thing is, as you are using the infrastructures of the grids, so you have to pay at least 10% of the electricity bills. Whatever will be the electricity, only 10%. Whatever will be the consumption, the 10% of that you have to pay for that. So there are different schemes, net metering, gross metering, etc., based on the capacity and the locations. And different states will find different types of tariffs. So hybrid power systems is also the options. Hybrid means the already mentioned the distributed power generations is nothing but the hybrid power systems, means combining different type of source. Here it is shown that wind turbine is also there, local generator is also there, PV system is also there, and there is some battery backup. And hybrid systems with grid connected systems, it is unidirectional, but nowadays the hybrid systems is bidirectional inverter is also available. Bidirectional inverter means if the power is excess, you can deliver the power to the grids also. So solar energy for electric vehicles. So you can develop some charging stations by using solar photovoltaic systems. Okay, charging stations means there is a market of electric vehicles. Electric vehicles is increasing rapidly. You are watching in the roads, but if you use the same electricity that comes from the grid systems to your households, and if you use that electricity to charge your vehicle, so there is will be no use, no use to the society, no benefits to our environments, because that is also that energy using that's also emits the carbon dioxide. So if you use the clean energy or the green energy, that can be done with the help of these kinds of system. Okay. And also there is another concept is also there, agrivoltaics. You can simultaneously use the solar energy with the help of agriculture. You know, there are some species of the plants that does not need huge solar radiation. Okay, so if you cultivate that species or that kinds of plants below the solar power station, so you can simultaneously generate the electricity as well as you can get the uh, agricultural product from your lands. So there will be a proper utilization of the land. So the concept is the agrivoltaic. And also in case of fisheries, you can go for the agrivoltaics. So cultivation of fish or the fisheries, as well as the generations of electricity by using some canal top or floating power stations on the ponds or the water bodies. So now these are the different systems already mentioned. Renewable energy options are there. Now, as we are researchers, what we can do? What's the different areas that we can work? So there are different areas are there. Different areas means you can go for application type of work. Application of solar energy means for powering the individual systems, standalone applications, and the for power generations and centralized grid connected systems, distributed power systems, and the hybrid power system, application of EV, hydrogen energy generations, etc. And the grid integrations of the renewable energies, applications of IoT, machine learning, artificial intelligence, different software like Homework, PDCs, MATLAB, Simulink, for proper system design, optimizations, and the estimations of the renewable energy potential for a site, etc. So what we can do, you can develop a hybrid energy systems. Hybrid energy systems. So you know the Homer is also there. So optimization softwares we are using. We are researchers are using. So Homer actually what does it do? It optimize the system based on the resource available for a particular sites. You can design these systems based on the load. Okay, and the based on the environment conditions, what is the resource available. So that type you can go for, and that for your research purpose. And also you can design a virtual systems also. And you know, for integrating the renewable energy into the grids, there is a huge scope of the work, because renewable energy and renewable energy intermittent indicators means there is a fluctuations of the voltage and the currents, and while there is a it needs a proper controlling arrangements of the systems. Proper control devices there, proper controller, converter, and the DC to DC converter, inverter, and the control arrangement should be there. So, and in that controller, in that, so there is some other aspects. Means it may generate the harmonies, it may create the problems on power factor. So it may just means the voltage, it may causes the problems of voltage regulation. So you have to choose the grid systems. You have to find the proper area where to feed the power based on the busbar conditions of the systems. So then only and properly you have to design the systems. Then only your research will be fruitful. So there are so many issues. So people researchers can work on that fields also. So research on advanced PV cells of the materials. PV cells means these are fundamental research that we do little bit. Every sectors we are working. means the compound semiconducting materials. You know, already mentioned the silicon solar cell. Mostly the solar cells is produced by silicon material, and the silicon has some drawbacks. Drawbacks means, you know, the band gap of the silicon solar cells is 1.1 eV. Band gap of the silicon materials. And band gap means why it is important? Band gap is important because whatever the solar radiations that coming at that absorbing by the materials, that needs to be absorbed, and based on the energy available, it should produce some extra electrons and the holes. And that extra electrons and the holes means if the energy level is more, uh, energy level is more than that band gap, then what happens? That energy will not be utilized. That will have the heating effects of the systems. Heating means, and the heating of the cells means that further creates the problems that reduce the efficiency of the solar cells. And and the energy below of that band gap, actually that will not be utilized. That will be the loss from the system. So the ideal band gap for the solar cell should be 1.4 to 1.6. 1.4 to 1. Why it is? You know, the solar spectrum, that is the container of the energy. Solar spectrum that contains the energy, that lies, most of the energy lies within the band region of 400 to 600 nanometer. Solar spectrum 400 to 600 nanometer, and corresponding to 550 nanometer, it causes the maximum energy, and corresponding 550 nanometers, the band gap should be 1.5 eV. So that's why I am telling the ideal band gap should be 1.4 to 1.6 eV. If it is less, so the excess energy will got lost, and if it is below that, say that energy will not able to excite the electrons within the material. So that's why we needs to have to search some alternative materials, alternative semiconducting, to have some alternative semiconducting device. Okay, and the compound semiconducting materials is the option. And also some inorganic materials is also, and the compound semiconducting materials are based on the inorganic materials. It's the compounding means the using different types of materials with a mix. It is produce some compound materials, and that and based on the band gap and the other properties, means the bulk resistance, contact resistance. Based on that, you have to design that materials. Okay. Now, organic materials is also the another options. The organic solar cells, organic semiconducting materials, that also can be used for developing solar cell. So now coming to some case studies of the small scale grid connected SPV power plants that we have. It is a very small power plants. Is values is 1 kilowatt. 1 kilowatt systems. Now it is damaged because of some ILA, and it is not ILA. It is just in the time of just some of the panels get damaged. So now it is not working. But before that, it was working properly. And per day we are getting is around 4 unit of electricity per day from 1 kilowatt systems. You can generate around 4 unit of electricity at Kolkata. So some case studies is also there. The solar cells modules is also there. Some measuring arrangements, some inverter, and some we publish some papers also in the conference. After that, it goes to energy procedure. So it is available. So design and feasibility studies of small scale grid connected solar PV power plant. So this is the another work we have carried out. It is published in Solar Energy. It is application of solar energy in pump systems. So in the pump, solar pump or solar irrigation systems, what's the beauty of irrigation, solar irrigation systems? You know, when irrigation is needed, solar radiation is high. Okay. And irrigation, you can run the pump in daytime, so you need not require to have any storage systems. And when irrigation is not needed, so solar radiation is less. So it is vice versa. Based on our requirements, you can make it operated. Okay. But the problem of solar pump in case of large scale pump, what happens? You know, solar radiation is intermittent in nature, and the solar radiation intermittent means there is a variations of the current. Already I mentioned solar radiation is directly proportional to current. So variations of the current means variations of the power, and that power is feeding to run the pump by some motors. Then there will be some fluctuations of the pump, and fluctuations of the motors in RPMs causes the fluctuations of the pump system, and fluctuations of the pump system causes some transients. And in the pump systems also, the through which the water passing, so the rate of discharge also in transient in nature, so may cause huge effects on the pipelines, water pipelines. So that needs to be mitigated by using some controller system. So we use here we develop some small scale systems, and we use here uh, means supercapacitor battery, small scale battery, lithium ion battery. We made some different combinations of that and make some experimentations and get the results. So anyone interested can go through that and get the results to find the means optimum arrangements of the systems. And also the solar energy for refrigeration systems, air conditioning systems, that you can go for. People can work on that also. So it is a one of the paper. It's a PV wind battery and the PV wind supercapacitor hybrid renewable energy systems using some Homer softwares. We optimize that and optimize a renewable energy systems, hybrid renewable energy systems. So there is another paper, the effect of the photovoltaic energy penetrations on a photovoltaic biomass lithium ion off-grid systems and the system optimization for the agroclimatic zones of West Bengal. Already mentions distributed energy generation system based on the local resource available. So as we know, we are diverse in nature. Okay, so and in West Bengal also we have around 5 climatic zones, and in different climatic zones, different kinds of resources are available. So based on that, you have to design a systems, and we have designed a systems, and we just try to validate it with the help of some other published. It's quite good paper. So anyone interested can go through these also. And now coming to their other several works also we have carried out. So it's not possible to put it here. I have not given here. So and also hydrogen is also there. Productions of the hydrogen, green hydrogens. We work on that also. And we don't have any practical arrangements to produce green hydrogen, but theoretically we are doing. And we are on the way to produce some practical setup. So some electrolyzer that will work on the with the help of renewable energy, especially systems, and how we can store that energy, hydrogen, and then we get from hydrogens for small systems or small fuel cells, how we can produce the electricity. There's some option. So there is a solar cells. Some advanced materials for solar cell applications. Solar cells are classified as first generation, second generation, third generations. Now we are passing to the third generation systems. Solar cells are advanced in nature, so we are using compound thin films is also there. We are also working on perovskite materials, dye-sensitive materials, organic materials, and also based on the spectrum of concept of ranging from low cost to high low efficiency system, dye synthesized organic solar cells to high cost to low efficiency. So these are the different materials we are trying to develop and uh, working on that. And also we are using some software to design the structure and to analyze its performance, then go for the laboratory experimentation. So these are the different types of solar cells and their efficiencies. It's available on the websites. It's published by National Renewable Energy Laboratory of USA. So it's everywhere. You'll get these results. What's the achievements? What's the performance changes? Because the solar cells, silica solar cells already mentions efficiency is very low. Efficiency is around uh, in commercial efficiencies 14 to 16%. In the monocrystalline, it is maybe is around 16 to 18%. And the theoretical efficiency, because the theoretical efficiency solar silicon based solar cells is around 29%. Because of that mismatching of its band gap. So that is the problem of that. And that's why we are trying to develop some materials that have the higher band gap. But there are some other problems also. So cost becoming low, but the problem is the stability is another problem. There is another problems of uh, resistance. Mean the bulk resistance, contact resistance means it is producing, it is generating, but how well, how easily we can extract that energy from the material or solar cells to the to our load system. So that's another problem. So we are working on that. So this is the photovoltaic technology status. The similar kinds of slides is here. So it is also showing the performance. So what's the lineup? What we can do? What is going on in this field of research? So these same kinds of slides, the efficiency of different types of solar cell material. Thin film is another options. Already the cadmium telluride thin film is available in the markets, but others thin film solar cells till now is not in the market. Compound semiconductor materials. So there may be a different combinations. So binary, tertiary, etc. Two elements, semiconductor silicon, germanium belongs to group 4. In the periodic table emerges the controlling the modern electronic industries. The compound semiconductors may binary, tertiary, quaternary compounds and the intermetallic components. So these are the different types. So the intermetallic semiconductor is also there, and the important 3 to 5 compound semiconductor materials means gallium nitride, gallium phosphide, gallium arsenide, gallium antimonide, indium phosphide, indium arsenide, indium antimonide. Produce a new wider choice of the band gap than elemental semiconductor. But the gallium material is a costly material, and some of these semiconductors have energy band gaps corresponding to the visible lights, and they apply to the light emitted diodes like gallium phosphide, gallium arsenide, others like indium antimonide, so etc. So the 2 to 6 compound semiconductors like zinc oxide, zinc sulfide, zinc selenide, zinc telluride, cadmium sulfide, cadmium selenide, cadmium telluride, mercury oxide, mercury sulfide, mercury selenide, etc. These are the material sulfurs, telluride of the group 6 elements are called chalcogenides, where HgAc, HgTe are same HgS is semiconductor. So these are the different types of compound semiconductor materials. So have different properties also there. It is also available. You can find the different band gaps of the different types of materials and different states. Okay, band gap, electron density, etc., etc. So we do some works in our PhD level. The works is also there, and later on some of my students carried out for developing CO2S materials for the PV applications, structural, optical, electrical calculations, and the fabrication of Schottky diodes. with silver as a counter metal partner. So that what we have carried out. We use some vacuum evaporation systems, vacuum coating systems. So coated thermally, it is coated thermally, evaporize that materials and make a coating over the glass substrate and make some device. Okay, so this is the system arrangements. I'm not going details of that. And there are another method is also co-evaporation of elements, depositions of the stack elemental layers, vacuum evaporations or prefabricated granules. So these are the different methods. So characterizations techniques of the fabrication films. So whether the material is correct, right or not, what's the performance, how it is well, so that can be determined with the help of these characterization methods. Whether the same materials what I wish to fabricate is deposited or not, so that to be checked. So with the help of these characterization techniques like structural, surface morphological, compositional, structural, means X-ray diffraction, scanning electron microscope, energy dispersive X-ray, etc., etc. FSM is also there. Optical characteristics also there. UV visible spectrophotometer, photoluminescence testing, electrical characterization like bulk electricity measurements, contact resistivity measurements, and IV characterization. To find its IV characterization, obviously it needs some device, and for that we uh, make some Schottky diode. So there are different uh, techniques, determinations of the bulk resistance and the contact resistance by transfer of the length model method, volume transfer methods, and we develop some another methods, that is evaluations of electrical contacts of thin film through AC measurements. Mostly the conventional methods are the DC measurements, but we go for different mathematical model considering the capacitance of the systems uh, for the thin film. Especially it is applicable for thin film. So that is also published in some IEEE papers. Evaluations of the electrical contacts in thin semiconducting films from AC measurements. Anyone interested can go through their papers. So get the idea on that. So you can work on that also. So this is the sample what we have prepared, CO2S for different methods. Stack elemental methods, we find superior methods. Stack elemental methods means the stacking, stack by stack. Uh, copper sulfur, and we make some different timing, different thickness within that, and ultimately we get the material. Then go for the annealing process, means the heat treatment. Then go for the grid, means preparations of the grid, means the some lining is there, metal lining is there, that to be needed to measure its resistance and its characteristics, and also then go for the silvers to make some device or some junctions, Schottky junctions we created, and go for IV characterizations. And these IV characteristics is similar to the photovoltaic cell or diode. So these are same characteristics. So it is also that ensures the uh, materials, the conforms the materials, means C2S is conform. S to the ratio is the stoichiometric ratio is 2.1, means Cu2S. So that we can say. And S3, sample 3, that is also showing here. And the band gap we measure, we get is around 1.7, 1.6, 1.8. Optical band gap we find quite high, and spectro band gap is quite low. So there is also its direct band gap is also, it is a direct band gap. So it is quite near to the 1.5 eV, 1.6 eV. So there are some other possible work is also there. I am not going elaborating more on that. So there is another fabrications of characterizations of copper-based semiconducting materials for optical application. That is also another paper. We prepared the CU2O, CUS. So these are the materials that also shows the semiconducting properties, and we use for developing compound semiconducting material based solar cell, with having the partner of CDS. CDS is the intermediate, and these are the p-type materials. C2S is the P-type semiconducting materials. And there is another options of copper nitride. So uh, there is a huge options of using the copper nitride is also that can be used for electric solar applications, as well as you can go for the LED applications. Organic material, it has found a different organic substance recently that indicates semiconducting properties, which shows wide possibilities to the researchers working on semiconductor physics and technology to go forward to have something with fruitful outcomes. A few of renowned organic semiconductors are rose bengal, methyl red, uh, melanchite green, crystal violet, phenolphthalein, and the methyl violet. So these can be used as a organic materials for developing solar cells or the other semiconducting materials, or the diode high speed electronic device means diode means MOSFET, etc. Advance of the organic semiconductors are these are the cheap rate, easy sample preparation techniques, lightweight device, highly flexible. Disadvantage semiconductors. Disadvantages are mainly since organic materials are amorphous and the disordered in nature. So it is amorphous and disordered. We don't have any crystalline structure. There is no crystallinity of the materials. As it is observed, means the molecules or the small crystals are there. That is discrete in nature, and there is a gap between that, and causes a huge problem. Causes huge problems means while transferring charge from one position to another positions, it offers a huge resistance. So material bulk resistance should be high, as well as it has a high trap energy. High trap energy means the charge is coming and that charge get trapped with some voids. Okay, so we will not get the power in the output, so efficiency will get low. So there's these kinds of problems. So high energy trap, significant trap distributions, and the trap induced impacts of the high series resistance. Finally, major problems of lack of ingredients available. Pure materials available in the laboratory is a problem. Although we know it is very much available, but the pure materials for laboratory purpose has a problem. As a natural, now there is another part, is natural organic semiconductor, a light of hope. Recently, semiconducting properties has been found in some of the common natural organic ingredients, which has named as natural organic semiconductors. Means it is available in our kitchen, in our garden, everywhere. Okay, these raises a hope to resolve the problem of lack of ingredients availability, and besides providing the advantage of other organic semiconductors, natural organic semiconductors is expected to be used as replacements of the organic semiconductors in near future. However, in terms of natural organic semiconductor is very recent in physics, hence it requires to be under the care of intensive research, and hopefully it may have the answer to so many vexed questions related to energy sectors and semiconductor based nanotechnologies. Gradually, physics of charge transport mechanism, characterizations of its electrical parameters, surface morphology need to be realized theoretically, and hence with proper practical experimentation. So we do some work on like turmeric, on indigo, on some spinach or some beetroot, etc. So what we do, we just take a in our lab we started some works into relevant materials, ingredients. Some means the so dyes the turmerics. You see the 10 gram as the experimental methods is written here. 10 gram natural dye powder formed from pure natural turmeric root is mixed properly in 100 ml of ethanol solutions at 60 degrees centigrade for 3 hours to prepare a dye solution. The mixture is then left to stir with a magnetic stirrer for next half an hour to have the homogeneity of the solutions. The aluminum sheets and the copper sheet is taken. The aluminum and copper substrates are then cleaned well for 15 minutes in distilled water by ultrasonic cleaner and hence left to dry. The substrate are then east with hydrogen chloride solutions to remove native oxides and those substances. And the film of the prepared solutions is then allowed to coat on the substrate with the help of a spin coater. The spin coater is needed. 100 rpm angular rotations at normal temperature. Pressure remains at millibar during the time of the film depositions with a few millimeter thickness range. The device is then fabricated and kept at a temperature of 50 degrees centigrade for at least 1 hour. Hence, the device is finally ready for packaging. So, what they do after spin coating of that material on the uh, copper substrate and the aluminum substrate, we made some sandwich in nature. So, copper and substrate, it is placed over there like this way shown here, and then after drying we go for characterizations. Characterizations means putting some energy, and we go for how much current and voltage with the help of some variable resistance current and voltage to get some IV characteristics. So this is the schematic of the working of this type of solar cell. So also or diodes. So this is the load. This IV measurement setup. Aluminum and copper are selected and placed as a front and the back electrodes respectively. A thin film of thermalic dissolutions is used as the active semiconductors we are deposited between the aforementioned electrodes. So uh, So, and what the thing we estimated parameters of the fabricated device. So these are the estimated. We just go for IV characteristics, and we find the rectification ratio, series resistance, ability factor, and the barrier height, trap energy, trap factor, brand bending. That can be calculated from the system. Anyone interested can go through this paper. It is clearly mentioned, given there. So investigations on the track signatures of organic semiconductors are and voltage analysis. So there is some other work is also there, published in solid state communication. So an analytical study of low voltage region of the natural organic semiconductor based device, physics of trap energy and DC factor. So these works is some part of experimental work and some part of theoretical work is considered to publish this kinds of research paper. So there is another work is the current transport mechanism, aluminum, copper, beetroot, copper used as an organic semiconductor. Schottky diode is the superior than natural dye-based thin film device. So the one that we can also understand. So now coming to the conclusion part. So energy utilization pattern is changing worldwide, harnessing chemical energy, renewable environmental friendly energy, technology with lower carbon footprint, conventional to renewable. So we are already mentioned this is we are energy transition. So most of renewable waste of energy like solar thermal, solar photovoltaic, biomass, high mature technology have the huge opportunity and the possibility as well as grid integration. Researchers are working on other technologies and advanced materials to improve the performance, uh, environment to make environment friendly, a longer life, easy of operation, reliable use, and the lower cost. Other than thick crystalline silicon solar cells, some of the other technologies are based on concentrating solar cell technology, thin film technology with nanocrystal silicon, amorphous silicon, metal-based compound semiconductor, perovskite material, etc. Multi-junction solar cells, they are dye-synthesized solar cells, organic solar cells. Although stability is the main problem of these kinds of organic or the other natural direct solar cells, major issues. So hopefully it will result in the future and will be commercialized soon. So there is a great interest in saving energy and in the use of the renewable energy. Hybrid renewable energy system with large pump storage, hydrogen storage, also hydrogen storage also will be the plants will help to resolve the problem of intermittency and be useful for uninterrupted power supply. Although there are some issues and challenges for using renewable-based energy, but have huge possibilities to go for sustainable development process by keeping our Mother Earth safe for our future generations. So that is very much important. We have to keep our Earth safe. We have to think for our future generations. So thank you very much for your question. We are I try to a huge means wide cover of the renewable based energy systems. Some get bored. But thank you very much. Thank you for your questions. So, any questions, any doubts you may ask me. So, thank you again. Hello.
Anyone, any questions? Can ask, sir. Anyone, any questions? Anyone, any questions regarding any?
If right now you don't have any questions, you can mail me or you can visit to our department. So, try discuss.
Anyone, any questions? If you have any questions, you can write to sir directly to his mail. We will provide all the details of sir's mail and details regarding how to contact him. Sir, I would like to have one question regarding agrivoltaic systems. Sir, if we want to work on a particular agrivoltaic system, means what could be the advantage of agrivoltaic? Like if you plant some particular I mean some plants under the agrivoltaic system. So, what could be the benefit?
You just want to know the type of the plant that's suitable for the agrivoltaic.
Yes, sir. And what could be the advantage area of that? I mean, suppose we are planting in under the sun, and we are planting some and the same type of I mean cultivation under the solar photovoltaic panel. So, what could be the advantage? I mean, possible advantage of that particular system, cultivation.
First thing whenever you put some agrivoltaic systems, means the photovoltaic systems in any if it is means
Sir, your voice is breaking, sir. Can you repeat once?
the problem of network, I think so. I also your voice also is a problem. So what I understand, you are asking about the advantage of the agrivoltaic system, okay, and the type of the species that that can be used, and you
we will have to wait for short time. Sir may rejoin again.
Sir is trying to join. Please wait, everyone.
Hello. Is it network problem? Okay, disconnected.
Yes, sir, you are audible now, sir.
What I was feeling. So if the land like Rajasthan, where the land is very bad condition. So in that kinds of lands, you can make fertile by using agrivoltaic systems. So that's the benefits we can get.
Sir, can we get some benefit over here under the climatic conditions of West Bengal?
Surely we can use it here also. We can use it in the tea garden. We can agrivoltaic is not only the agriculture means the you can go for fisheries also. Okay, so we have a huge wetlands. Okay. That can be utilized for cultivation. That can be used for the fisheries. That can be used for power generations also. That combination uh, means the as well as the constructed wetland. Wetland means the wetland management to have a good environment. So these facility these kinds of work we can go for as a case studies.
Sir, in case of like hydroponics farming, so where we don't require any kind of soil, So in that particular one, how it could be helpful, agrivoltaic?
Uh, if soil is not required means so if it is a vasted wetland, so that may be planted in the water bodies, and over that you can put some the land is there that can be utilized for power station. You can go for solar power station. You can go for wind power stations. In between that
Okay,
means
thank
the
you, sir.
combination of agriculture as well as energy, renewable energy systems. So that is the concept of photovoltaic. Okay.
Okay, sir, I got it. Anyone else would like to have some questions? Okay, sir. We are truly honored to have you with us today. Your presence has guided us in acquiring new insights on sustainable energy, inspired us to explore innovative research areas in the field of renewable energy, energy security, energy efficiency, energy conservation, energy planning, and sustainable development goals. On behalf of all the participants, faculty members, and organizers, I once again extend my heartfelt gratitude to you, sir. We look forward to our gracious support. We look forward to the future collaborations in working with you. Thank you, sir.
Sir,
Thank you.
hello,
Sure.
hello.
Sir, Shweta madam wants to have some questions, I think.
Yes, sir.
Okay, Shweta madam.
Sir, I have one question, sir. How that renewable energy play an important role in that type of climate change?
Sir, I
It's
will repeat
obvious.
it.
Hello.
Climate change. What is the main culprit of climate change? You have to understand the main culprit. What is the problem? Main culprit is the greenhouse gas. So if you can reduce the greenhouse gas emission, and the greenhouse gas is emitted, most of the greenhouse gas emitted by energy sector. You are using fossil fuels. That fossil fuel creates like combustions of the fossil fuels. It produces carbon dioxide, delivered to the environment, increase the greenhouse gas levels, cause the problem of global warming. So, and also cause the problem of climate change. Okay, so if you can reduce the carbon dioxide emissions, and that can be done only by using the alternative